So yesterday we worked on multiplying and dividing rational functions. How do you feel about that? We factor stuff, we simplify by canceling stuff, go from there, right? So today we need to add and subtract. Is that okay? Today we need to add and subtract. So let's start with stuff we already know how to do and figure out what steps we used and then work on rational expressions. Very similar to what we did yesterday, yes? Okay, so let's start. Start with what we know. 3/7 plus 2/7. What do we do? No, I'm not asking for the answer. I'm asking you how to do it. Straight across. So 5 over 14? You guys are telling me like I don't know how to do this. You're telling me stuff and I'm trying to make sure you can enunciate it properly so that you know what you're doing. By saying add straight across, when I said 5 over 14, that's what I did what you said, right? Is that what you meant? What did you mean? Add the numerators. What do you do with the denominators? You keep it because it's a common denominator and that's what you need in order to add or subtract fractions, right? So I'm not trying to pick on you. I'm trying to make sure you have the correct vocabulary. Is that fair enough? Okay. So what steps did we do? Added the numerator. Put all of it. Oh, okay. What? Not yet. All right, so what if it looks all messy and ugly like this one? Do we care? Because does it have a common denominator? If it has a common denominator, what do? We add the numerators. What is that? Oh, Lord. X plus 2, and then I keep my denominator, right? Remember, we're adding, we're not multiplying, right? Right, okay, awesome. What about if it looks even messier like this? We don't throw up, or if we do, we're going to go in the hall, right? Yeah, not on the carpet. So x squared plus 1, I keep my denominator. What do I do with my numerator? I add, right? 2x and 5x, 7x, negative 3 and 7, plus 4. Done. You okay so far? Yes or no? Okay. What about this one? How is this one different? So we subtract numerator. So what do I get? 8 minus 3 is 5. 11 minus 11? Oh, I don't do that, do I? Oh, okay. It stays, right? Keep the denominator. So what if it looks really ugly like this one? Still fine. X plus 6. Can I tell you what the wrong answer is that a lot of people tell me? X plus 20. First of all, why is it the wrong answer? They added everything? So we say 2x minus x. Is that fine? That was x, right? 11 and 9. Oh, no? Okay, 11 minus 9. Oh, okay. So do you see where they tripped up? Don't let yourself be tripped up there. Okay? Don't play yourself. That's exactly right. Go cash yourself outside or something. Something. Yeah. Okay? This is even worse, right? This is even uglier. It's still fine. I keep the same denominator. Okay, so negative 8x minus 4? Why is it plus 10? Wait. Time out. I've lost somebody. I got to catch them up. X minus 9x. That's negative 8x. You okay where that came from? Okay. 3 minus negative 7. Yep, plus plus. 3 minus a negative 7. Plus plus. Plus 10. You good? So the problem comes, and what I mean by problem as in the math problem, the problem comes when we don't have a common denominator, right? So here's what I want you to think about. I want you to listen to me for a second, please. I know where we're going, and I know what thought process we need when we get there. So I want you to think about the thought process that I'm asking you to do. Fair enough? This has a denominator of 8. This has a denominator of 4. I need them to be common. Is there anything I can multiply by 8 to make it become 4? That's a whole number. 8 times 2 is 4. So is there anything I can multiply 8 by to make it become 4? Then I don't need to worry about that. I need to look at the other one. Is there anything I can multiply 4 by to make it become 8? 2. Oh, that's the 2, right? Think about this also. Isn't 8 4 times 2? So if they both have a 4, what does this other one need? A 2. If I multiply this one by 2, I have to multiply the numerator by 2 also. Why? I get what you're telling me, because that's what has always been told to you. If you do it to the bottom, you always have to do it to the top. My question stands. Why? If I multiply something by 2 over 2, what am I actually multiplying it by? 1. 1 is the only number I can multiply something by and not change its value. In this particular case, I'm choosing my 1 to be 2 over 2, because that's what I need in my denominator. Do you understand? It's not just because that's what you do it because that's what you've always been told. You're right. You do it because that's what you've always been told. I need to make sure that you know why. You okay with that? So what I end up with is 3 over 8 plus 2 over 8. And then we just follow our rules from up here, right? Add the numerator, keep the denominator. Here, I'll let you use one abbreviation. How about that? What does that mean? Very, very good. Get a common denominator. Add or subtract, depending on the problem. Numerator. Very good. Okay? All right, look right here. What do both denominators have? They both have an x. So we for sure want that to be part of our denominator. What is this one missing? A 3. So I'm going to multiply that numerator and denominator by 3 to help me figure out what my answer is going to be. The first one stayed the same, so I'm going to leave it alone. What does the second one become? 3x plus 3. Yeah, because remember I distribute, right? Over 3x. Now I have a common denominator and I've simplified my numerator. So now what do? Add or subtract my numerator. 3x, very good, plus 8 over 3x. Then I cross out my 3x's. We are not ridiculous little children, are we? We are not ridiculous little children, so we cannot cross out the 3x's. Well, this is the factor of the bottom. Is this 3x a factor of the numerator? It is not, because there's something being added or subtracted to that 3x. Does that make sense? If I could factor out a 3x from this term, then I could go around about canceling out 3x's. But just because there's one in the numerator and one in the denominator doesn't automatically mean I can cancel it out. Okay? All right, what about this one? Before I do anything, I want to factor, right? Wait, did that help me? Ooh, that helped a lot, didn't it? Because now I can see that each one of these denominators have a x plus 2, right? What does this second denominator need? A 2 multiplier, right? So if I multiply that by 2 and that by 2, that will help me get my common denominator, won't it? Okay, so my first fraction stays the same. I didn't have to mess with the denominator. But my second fraction becomes what? 18 over 2 times x plus 2, right? So what do I get for my answer on this one? X minus 17. Why do I leave it 2x plus 2? It's a good question, okay? I could very easily write 2x plus 4. Just multiply it out, okay? But what would happen if I did all my multiplication and all my addition and subtraction in the numerator and I got an x plus 2? I would have to factor this back out to be able to simplify like we did yesterday, wouldn't we? So I might as well just leave it factored. It's not wrong to multiply it out, not at all. If you multiplied it back out, I'm not taking points off at all. Okay? I'm just leaving it just in case there is something I can factor in the numerator. Yes, if you would have written x minus 17 over 2x plus 4, that is absolutely correct. Okay? All right, look at number 4. Example number 4. Yeah, right? So we do have to find a common denominator. This one doesn't have anything in common like this did up here, right? These both had a 4. These don't have anything in common at all. In fact, these two are both prime numbers, aren't they? When in doubt, multiply. Yep, you would. What does the first one need? It was a 7. It needs a 5, right? Multiplied by 5. So what does the numerator become? 15. What does the second one need? Like what factor is what I'm asking, right? So it needs a 7. So the top one is a 14. I know what you were saying. You were already answering my question, my next question. That's okay. 29 over 35. Okay? So it's really the same steps. I'm not going to write them again because I'm worried about time. I want to get to these two over here. But I can go like that, right? Ditto. Ditto those instructions. Get a common denominator and then either add or subtract the numerator. Okay? What's my common denominator here then? 3x. That's exactly right. The x needs a 3 and the 3 needs an x. Okay? So in the first fraction I end up with 15. The second fraction I end up with 2x squared. And when I subtract them, yes. And that won't matter what order. Typically we write the x's first and then the constants. Yeah. It also is not something that would be counted wrong. Okay? What about the last one? Multiply them by each other. This one needs a 2x plus 1, or excuse me, minus 1, and this one needs an x plus 3. So my first fraction is going to end up being 8x minus 4 over 2x minus 1, x plus 3. And my second fraction is going to end up being 7x plus 21. You okay? They both needed the other one. This one needed a 2x minus 1. This one needed an x plus 3. If I multiply denominator by it, I have to multiply numerator by it so that I'm multiplying each fraction by a value of 1. I distributed the numerator to the thing I was multiplying by and got x minus 4. I distributed this numerator to the thing I was multiplying it by and got 7x plus 21. Now all that's left for me to do, 2x minus 1 times x plus 3. Okay? When I add my numerator, what do I add? The x's, so I'm adding like terms, 8x and 7x, negative 4 and positive 21. Plus 17. All right, look at this page right here. It's the third page. It's the second piece of paper, but it's the third page. You understand that? There are 8 problems on this page. Choose 5. Perfect timing. Have a great day.